Right, here we go. So this is module 3. It starts off with rational functions. There are two homeworks on this. A 4.2, 4.3 basic rational functions and a 4.2, 4.3 advanced. And we're going to cover it all in one go. So what we're going to learn about, we're going to learn about vertical asymptotes, holes in the graph, horizontal asymptotes, or oblique or slant asymptotes. So let's start off with an example, 2 over x squared plus 2x minus 3. Now, the degree of the top is 0 because it doesn't have any x's in it, and the degree on the bottom is 2 because it's a quadratic. So here is case 1, degree of numerator smaller than degree of denominator. So my degree in my numerator is 0, the degree of my denominator is 2, so just think about that the bottom is bigger than the top. And because the bottom is bigger than the top, what that's going to mean is our horizontal asymptote is y equals 0. What the horizontal asymptote is, it tells us what the graph is doing as we approach infinity and negative infinity. And you'll see in a minute when I show the graph. Okay, so the degree on the top is 0, the degree on the bottom is 2, so it's case 1. So the horizontal asymptote is y equals 0. Do not say 0, say y equals 0. The horizontal asymptote is a line. Y equals 0 is a line. 0 is a number. Right, now if we go ahead and factor this, now we can talk about the vertical asymptotes. Now, it turns out that the vertical asymptotes, and I have a star here, are usually where the denominator is 0. It's not completely true that if the denominator is 0, the vertical asymptote is there. But for now, let's just pretend that's the case, so because we're just learning about it. So the first thing I'm going to do is I'm going to factor my problem, and I'm going to do 2 divided by x plus 3, x minus 1. So we know that we can't plug in negative 3 because you can't divide by 0. And so the domain is I can't plug in negative 3 and I can't plug in 1. So my vertical asymptotes are x equals negative 3 and x equals 1. So now what I'm going to do now is I'm going to do a little graph. So I've drawn my graph right here, and this line right here, whoops-a-daisy, whoops. And this line right here is the line x equals negative 3, this dotted line right here. So and then this dotted line right here is x equals 1. And the graphs do not touch those vertical asymptotes. So you cannot cross the vertical asymptotes, but you can cross the horizontal asymptote. The horizontal asymptotes, y equals 0. Okay. So you can see that the graph is dropping to 0 on both sides over at infinity and negative infinity. Okay. All right. So now let's move on to find the vertical, horizontal, oblique asymptotes, if any, for the following rational function. So my degree on the top is 1, and degree on the bottom is 1. So horizontal asymptote, case 2. Degree of numerator equals degree of denominator. Then the horizontal asymptote is leading coefficient divided by leading coefficient. So my leading coefficient here is 19, and my leading coefficient here is 1. So I get 19 over 1, y equals 19 is my horizontal asymptote. Now, cannot divide by 0, so I can't plug in negative 16. Negative x equals negative 16 is right here, and here is my graph. Again, you can see that what's happening is it's going to 19. So for some reason, my picture is not right. All right, so we like that, there you go, and we like that, and so the that's y equals 19. Good. All right. Now, Determine whether the graph of the rational function has a horizontal asymptote and oblique asymptote or neither. Give the equation for the asymptote if it exists. So the degree on the top is 2, the degree on the bottom is 1. So the top keeps getting bigger and bigger, so it's going to go off to infinity. So no horizontal asymptote if not case 1 and not case 2. So this is clearly not case 1 and not case 2, so there's no horizontal asymptote. So no horizontal asymptote, but it will have an oblique one or a slant asymptote. It is the quotient of the long division. So I go ahead and do my long division, and here is my oblique asymptote. So you can see I've graphed it right here. And here is my vertical asymptote of 4. And here's my y equals 3x plus 18. And you'll notice that the graph as it goes to infinity and negative infinity and positive infinity is heading towards this line. All right. Okay, so now we're going to turn it up a little bit, make it a little bit more complicated. So find the vertical asymptotes, if any, and the values of x corresponding to holes, if any, of the graph of the rational function. So first of all, vertical asymptotes occur when the denominator is 0 and the numerator is not 0. You get holes if the denominator is 0 and the numerator is 0 at the same time. So let's go ahead and look at this one. So A, I cannot plug x equals 0 in, and I cannot plug x equals -5 in. But if I plug in -5, I get 0 on the bottom, but not 0 on the top. So this one's a vertical asymptote. If I plug 0 into the bottom, I get 0 on the bottom and 0 on the top. So it's a hole. Now, if you actually want to know the coordinates of that hole, the x value is 0. To figure out what the y value is, you can cancel the x as long as you remark that you can't plug in 0. And now if I plug in 0, I will get 1/5 right there. So the coordinate of that point is 0, 1/5 because I plugged 0 in there. Okay? All right, another example. Find the vertical asymptotes, if any, and the values of the x corresponding to holes, if any, of the graph of the rational function. So first of all, it doesn't ask about this, but the horizontal asymptote is going to be y equals 0. All right, so first things first, I factor the top and the bottom. I can't plug in 7 because 7 will make that 0. I can't plug in 3 because 3 will make that 0. But if I plugged in 7 here and I plugged in 7 here on the top and the bottom, I'd have 0 over 0. Again, I can't have 0 over 0. So x equals 7 will be a hole, and then x equals 3 will be a vertical asymptote. If you want to know what the coordinate of that hole is, simply cancel this and then plug in 7. There we go. See how easy that is? All right, now for a word problem. All right, so this word problem is an engineer is designing a cylindrical metal tank that's to hold 475 cubic feet. All right. Okay, so the height h is a function of the radius, and we're given this volume formula. So we know volume's pi r squared h. So I'll solve for h by dividing both sides by pi r squared, and then I'll replace v with 475. Height is feet. So if you did the dimensional analysis, there would be a feet cubed in the top, and this r squared would be a foot squared in the bottom, and then that would cancel out and I'd be left with feet. So when you do physics, you need to do the dimensional analysis. Not in math, you just need to put the dimensions at the end. All right, so this is surface area, so it's going to be a foot squared. All right, so what we're going to do now is everywhere in our surface area problem, 2 pi r squared plus 2 pi r h, where we see h, we're going to replace it with this. So you can see that I've just simply replaced h with that and then done some simplification of my algebra. Part C asks you to graph it, so I graphed it. I went from 0 to 10, and then I just used a zoom fit. Then I used the minimal feature. Now remember that this is the function s. So this is in feet squared, and this is in feet. So this gives me my radius, which is in feet. This gives me my s value, which is surface area. So the best radius I need is 4.2 feet. And then my surface area is 337 square feet, and it's $7 a foot per square foot. So this is 337 square feet times $7 per square foot. Square feet's cancel, and I'm left with dollars. And that is that for 4.2, 4.3. So you should have a good idea now of how to go about doing the homework.